Hello everyone. Today's video session is on interfaces in Java. We'll cover what interfaces are, how they work, and some practical examples. Let's dive in. Why do we even need interfaces? Can we just create classes and be done with it? Well, what happens when different classes need to share similar actions but don't share a parent class? That's when interfaces steps in. An interface is a group of related methods that have no implementations. It defines what a class should do, but not how it does. Interfaces are essential for abstraction, polymorphism, and multiple inheritance. They cannot be instantiated on their own. For example, an interface animal might have a method sound without a body. Some key features of interfaces include methods are by default public and abstract. Fields are constant, meaning they are public, static, and final. Classes implement interfaces using the implements keyword and must override all abstract methods. Java allows multiple inheritance by letting a class implement several interfaces, which helps in defining behavior across unrelated classes. This is an example of interface implementation. In this example, we define an interface called animal. It has a single abstract method named makeSound, which does not have any implementation. Next, the dog class implements the animal interface and provides the concrete implementation of the makeSound method by printing woof woof to the console. In the main method, we create an object of the dog class using an animal reference. This demonstrates polymorphism. The interface type can point to any class that implements it. Finally, we call the makeSound method using the animal reference, and the dog's version of the method is executed, printing woof woof. This shows how interfaces helps define behavior that can be shared across different classes. This is an example of multiple interface implementation. In this example, we define two interfaces, drivable and flyable. The drivable interface has an abstract method drive, and the flyable interface has an abstract method fly. Next, we create a class called flying car that implements both interfaces. The flying car class provides concrete implementation for both methods. The drive method prints driving on the road and the fly method prints flying in the sky. In the main method, we create an object of flying car class and call both methods. This implements how a single class can implement multiple interfaces in Java, allowing it to have behavior from different sources. This is a powerful feature because it helps Java support multiple inheritance, letting classes combine functionalities from various interfaces without the complication of multiple parent classes. This is an example of default and static method. In this example, we have an interface called animal. It includes a default method named breathe and a static method named info. The default method provides a standard implementation that any class implementing this interface can use, while the static method belongs to the interface itself and can be called without creating an object. Next, we have a class dog that implements the animal interface. It has its own method sound, but it doesn't override the breathe method, so it inherits the default behavior from the interface. In the main method, we create an object of the dog class. We call the breathe method on this object, which executes the default method from the interface and prints breathing. We also call the info method directly from the interface using animal.info. which prints animals are living beings. This example shows how Java introduced default and static method in interfaces to provide reusable code and additional functionalities without forcing all implementing classes to provide their own implementation. This is another example of iterative and decision making. In this example, we define an interface called alarm that has a single abstract method checkAlarm, which takes the current hour as input. The security system class implements the alarm interface and provides the logic inside the checkAlarm method. If the hour has 22 or later or earlier than 6, it prints that the alarm is on. Otherwise, it prints that the alarm is off. In the main method, we create an alarm reference and assign it to a new security system object. Then we use a for loop to check the alarm from hour 20 to 24. We use hour to ensure that 24 hours around to 0, simulating a 24-hour clock. This example shows how decision making with if conditions and loop can be implemented inside interface methods, making the behavior more dynamic and realistic. Hope this video was informative. Thank you.